Now, so as input slash output pins, you may or may not need to specify the input output direction. That is whether for input or output. Okay, and I'll show you why. And that has to do with the electrical property of these ports. Um, yeah, and other architectures or extensions of the architectures may allow you to specify the pin drive strength, and also that's more specifically that's in terms of the value of the pull up resistor or pull down resistor. And we'll look at these, maybe not this time, but later. Some general purpose I/O ports are tied to interrupts. Again, these are more advanced features we'll look at later. Okay, so there may be associated special function registers for various I/O configurations, but we really will start with just the basics. Now, just to make sure we know the notation, now this is really the I think a pretty common way to denote these elements in the schematic. So a bus is what's called it's a group of wires, and it's drawn with thick or relatively thick wires. And a port is drawn usually with a rectangle like that. That allows you to connect from one part of a schematic to another part of a schematic. Instead of having to draw everything, you just name these so they will associate by name. And you can tap off parts of a bus. It's usually called a breakout. So, for example, you have a data bus, and that goes to like D0 to D3, or address bus goes from A0 to A3, and then you tap off individual lines as A0, A1, A2, A3, and so forth. Okay, and so that's that first. And since we're talking about more the electrical level, well, first you have to have the different voltages, right? So ground versus supply power. Now, so there's different kinds of ground. A generic one might just say GND. And then there's power ground, which you draw with these horizontal wires. Signal ground is what you might see a little bit more. That's what general purpose I/O ports deal with. So when you have the GPIO P0, P1, each one actually is a signal. Okay, a signal is trying to convey some value. Okay, it could be an analog signal, it could be a digital signal, but it's conveying a value using its voltage. It's not meant to be a source for like driving a light, an LED, for example. It's really an indication of a value. It's not meant to be a power supply. Okay, and for that reason, oftentimes you'll see this triangle pointing down as a signal ground. And then there's earth. That I think is used maybe more with antennas or something. But anyway, there's different kinds of notations for ground. And why do you need a ground? Because you really need a reference, right? How do you know if you have a voltage that's high or low? Well, it has to be relative to the ground. Without the ground, you have no reference, and it could be anything, right? So, and that's actually common mistakes for a lot of these beginning embedded system projects, is they have a bunch of things, but they forgot to connect the grounds together. So you can have the signal, the port pin is connected, but it's not relative to any ground, and so you can't see any effect. So the ground has to be connected. Okay, that's very important. Okay, and other or some are for really electrostatic discharge. So earth, for example. I guess people nowadays might not worry as much about the static discharge, but I had to worry about it. That is, before handling a chip, you better discharge yourself, like sometimes with a strap that's connected to metal ground or earth, so that when you handle a chip, you don't zap it and destroy it permanently. Yeah, I think that you still want to be careful, but yeah, so that's why there's different kinds of ground there. Okay, and another thing you might want to know is this concept of a pull-up. So what's a pull-up? A pull-up is basically a resistor that's tied to a lot of times, the supply level. And it could be like 5 volts, and sometimes that's VCC or VDD. And then, yeah, so that's a resistor there, well, really for the purpose of limiting the current. Okay. And so, for example, if you have a push button, that's usually the way it's connected. That is, the button is usually disconnected, right? And when you press it, it connects the two poles or two terminals together. It could be just a single pole. It doesn't have to be like contact like that, right? But you get the idea. One end is attached to ground. The other end, on the upper side, is attached to a pull-up resistor. And the value you read out is on basically the end that connects the pull-up and the button. Okay, so by default, the V out there is the high value. Okay, if you measure the voltage, it's the same as 5 volts. Okay, and then when you press the button, it pulls it down to the ground. That's how most push buttons work. Okay, and then when you release it, it goes back to the high voltage. And the resistor is there also to serve a kind of a protection purpose. It limits the current because with a resistor, right, you can limit how much current it can flow through, because you have to prevent somebody there, like V out. If they just attach it to ground, then if you don't have the R, you have a short circuit, right? So the R there is to limit your current. And when it's high and you're measuring just the voltage, there's not a lot of current flowing through, then that's okay. Okay? But it's there. Like also when you press the button, it has a path to ground. And the R there, the resistor there, serves the purpose of limiting the current. If you don't limit the current, it's a short circuit and it will blow up. Or might not blow up, but smoke will come out. You'll smell it. Okay? So be careful. Now, so as an I/O port, that means the port can do input, it can do output. But how do you know when it's doing input or output? Well, there are different ways to do this. The original 8051 way is, well, what I call option 1 is you are always outputting, but you set the port to 1 when you want to input. And then there's the option 2, which many other microcontrollers do, also including the CC2540 extension, is you have a way to set the direction of your port. You would write some values to a special function register to say if you want to input or you want to do output. Okay, that's what I call option 2. So option 1, which I'll tell you more detail in a little bit, Uh, basically, you're always outputting, but if you want to input, you set the port to 1. And internally, it's done using what's called an open collector with a pull-up structure, or in that case, that makes it a closed collector. But anyway, and this means it allows somebody to, or on the outside, to override your input, your port value. Okay. Option 2 basically configures each port for either input or output. And then you shouldn't be mixing the input and output actually together.